Then this is regarding factor of safety. If you want to design a component under fatigue cycle, it will have both component of static, that mean stress, and cyclic load. And you want to, obviously you don't want to take risk of exactly falling into in the line, whether Goodman or Gerber or whatever. It should not fall in the line. That means a failure, but it will be far away. So for this amplitude, for combination, you know what is the stress amplitude and mean stress, it falls here. And if you have a that curve alternate stress versus tension in x-axis tension and compression mean stress, and obviously this red line is very generic because structure we don't allow for yielding, so in mean stress also should not go to yielding, and your endurance amplitude should not go beyond yielding. So this is the yield envelope in tension side as well as compression side. And if you use a Goodman line, of course as per the equation, start with ultimate, and r is equal to -1, it will be endurance limit, and compression it remain constant, there is no change. So to define what is the factor of safety, how far up from your, like in static you have done margin of safety, a reserve factor, right? It is basically to know how far margin from the failure. Similarly in here, how far from the, because the line itself is the boundary of the failure. Any combination of stress amplitude and mean, it falls in the line. This combination of stress amplitude and mean in tension side, it will fail. Or stress amplitude this much, okay, if you are not exceeding yielding, it is here, this combination mean and this amplitude will fail. But if it's far away, you have some margin, safety margin. So factor of safety is given a ratio of green versus, that is from here to here. So this is a comparison of things. If you have a Soderberg, the point is here, amplitude versus mean is very far safe off. And there is one more terminal is called modified Goodman line, because Goodman is using ultimate stress like SU, right, in the denominator. But of course here you have a red line, yield line, you should not accept. So sometimes that can be replaced with this modified Goodman, nothing but numerator you are changing to, but nobody talks about modified Goodman equation when you do the correction for the mean stress correction factor for the Hessian curve. It's always Goodman, because always your mean stress will be well below this. It is a very conservative site, so that's why they don't worry about the Goodman, modified Goodman's line. Now coming to the factor safety to ensure, now we are strict into Gerber, Soderberg, anything example. To ensure the factor safety, you need to have this sometimes they called small n or capital N, SOF, factor FOS, factor of safety, like that. So instead of 1 is a factor safety, means you are having some cushion depending on the design's requirement, whether you want to have a factor safety as 1.5 or 2 or 2.5. So that gives the 1 by n and things. So with the Gerber equation there. Here there is no 1 n because it's not linear. So n is kept in the left hand side, will be n square. If you want to bring the n, it's not possible. If you want to bring, then there will be one more n in the second term, right? N square will come out. You divide n in to keep right hand side 1 by n. You divide by n here in the right hand side of equation 3. Here n will get cancelled, but n square by n. So instead of that, they are putting, but the fact that n is here. We'll see some examples how it